Hello everyone, welcome back to the third part of my series on making a Discord bot using Node.JS with a custom programming language. So in this episode we're going to be implementing the programming language so that it can actually be run. So first we're going to want to go to our language.js file again, and in the last part, in part 2, we added iter and program. So far what we have is we have the basics of our language defined, and then we started implementing the actual program and how to execute it. So far we have implemented a program, and when a program is run, it should just run all of its lines in sequence. So now let's start adding some of those lines. So let's actually split the view like this so we can see our structure on the side. So we have a line, right? So we have a line, and a line is a statement followed by something like that. So how we represent this in the semantic version is we can do line is an async function which takes a statement, and the statement is this statement part here, this part, but it also takes this part as a parameter, and this part we don't actually need it, we're just going to call it underscore. Yeah, so we'll just call that underscore. And what we want to do with this is we just want to return the value of the statement. So what this is going to do is we have a program, it runs each of the lines will just run the statement inside of it. So let's look at our statement part now. A statement in our program right now is just assignments. In future parts we're going to add more statements such as functions, if statements, and switch statements. But for now we're just going to do we're going to implement all of the different expressions and comparisons. First we're going to want to implement the basic expression, which is right here. We want to do statement. A statement right now is an assignment. So since we have this nicknamed part of our programming language, assignment, what we'll call this is statement underscore assignment. And this will be another asynchronous function. The reason why we do async functions is so that later on your program can depend on asynchronous things, and it'll wait for things to happen. So now we have assignment, and the parameters for assignment are an identifier, which we're going to need, so we'll just take that and call that ident. And then we also have the symbol, which we don't want, so we'll just ignore that by calling it underscore so that we remember that we don't actually want that. And then, or let's actually call ident, which is going to be the name of the variable, we'll call that right instead. So we have the right, we're going to let's make a new variable called value right. So this is going to be the value of the statement on the right, or the value of the expression on the right, and that's just going to be what happens when we interpret right. And now we need to set up some other things. So we're going to set up the environment that the program runs in. So this is what we needed Lodash for. So up here, before we define our semantics, we're going to do var environment, outside of here we need to create a variable called original environment. So we'll just, for now, environment is this, just like that for now, and we're going to go back here, and now we'll do var environment is underscore dot clone deep environment. So if we remember up here, the underscore is Lodash, And what Lodash allows us to do is just a bunch of helpers so that we don't have to write out things like this async for each for everything that we want to use. So our environment is just going to be a clone. So it's just going to be the original environment, basically. But it's going to be modifiable by our program, and then future runs of the program won't have the same variables set. It won't have the same environment. So now that we have the environment, we want to go back to assignment, and we'll do var again, no. Yeah, okay, we'll do value left. So the value of the identifier is just going to be left.interpret. So we'll just interpret the left side. And then now we can set environment value left equals value right. So now we're just setting in the environment, we're going to remember that for the key, which is going to be our ident, which is going to be equal to the value of the expression on the right. And then we'll return right. Value right. Yeah. Because when we do an assignment, we want this actually return doesn't matter, I don't think. No, it's important because if it's the last one, we want to display the last output of the program. So now let's do some other expressions. So first we're gonna do all the expressions now. So an expression in our language is an OR expression, if you remember over here, expression equals OR expression. So this is basically just gonna pass it on. Function E is gonna be our we're just gonna call our expression that, and then we'll return E dot interpret. So this is our basic pattern for passing on the expression or the call. So this is going to be the basic pattern for passing on any call. So we already used this once in line, because a line is just the value of this. The value of a line is just the value of the statement. So now we'll do the OR expression. So an OR expression, no, OR autocorrected is, if we look up here, an OR expression has two things. So it could be an OR it could just be we just called it last, and that's just for passing it on. And we forgot to do that for this one. This needs, we need to change the grammar again. So we're going to close this for now. We need to go back to the grammar. An OR expression can also be an AND expression, and can be a comparison. We don't need the last. We don't need this. No, we need this, but we don't need to call this part last. So we'll have comparison math. This one needs to be also a math exponent expression. Prefix expression is good. Okay. So now we'll go back to our language, and we'll split this back. Right there, and then we can hide this one for now. So now, we're going to do the OR expression. So an OR expression can be the or it can just pass on to an AND. So if we're not passing it on, we're gonna do, or if we are passing on, so if we're doing this second one here, we're just gonna do the basic pattern basically. So we're gonna return await e.interpret. But if we are doing the or we'll do that next. So now we're just gonna copy and paste this a couple times. Or 3, 4, 5, 6, 7. Yeah, 7. Okay, and then we'll start by doing the AND. So we're just going to set up the ones for when it needs to just pass it on to the next. So what this is going to do is it checks if it's an OR expression. If it's not an OR expression, it then checks if it's an AND expression, and then if it's not, it'll check if it's a comparison expression, and if it's not, it's going to check if it's a math add expression, and if it's not, it's going to check if it's a math multiply expression, and so on. So next we need math exponent expression, and then we need prefix expression. A prefix expression. Wait a minute. Oh, this is wrong. Okay. This is also wrong. Prefix expression. This is not a prefix expression. This should be called literal expression. And there should be prefix expression. Prefix expression can be negative literal. So this is to make a number negative. We can have not a literal. So this is called not. Or it can be a literal expression. And literal expression, okay, that's correct. So now we go back over here again. Prefix expression, okay, and then literal expression is literal expression doesn't need one of these. So first we're going to implement OR. So for OR, we're going to OR is going to be, let's pull it up. OR. So OR expression is OR expression underscore OR. Just like we did in statement assignment, we do OR expression underscore OR is an async function. This one will take, if we look back up here, we have the left part, we have the right part, and we have the OR. So we'll do X, ignore the middle part, Y. We need the comma here. And for OR, we'll do X, or value X. The value of X, the value of the left side is X.interpret. The value of the right side, Y.interpret. Now we want to just return X or Y. So we'll just map this function in our custom language to a JavaScript built-in operator. And in a future episode, we're going to add in type checking so that it doesn't break when you try to do like 1 or 2, like with numbers instead of with the booleans like it should be. Now for AND, we can pretty much just copy this, paste it here. We want to change this to be called AND because that's what it's called on the right in the AND expression. An AND expression, we're going to do, it's still value X, value Y, but instead of OR, we're going to change it to AND, like that. Comparison expression is the next one. This one takes a while. We want, okay, we're going to have a lot of these. Comparison expression less than or equal to is async function X blank Y, and then we'll just copy paste this part in. we'll do that. Then we'll return x less than or equal to y. In a different future episode, we're also going to, there should be empty. We're gonna change the number library that we use instead of built-in JavaScript numbers to use a library called big integer, which is more verbose, but it allows for much smaller and much bigger numbers, and it won't break as much. So for this, we're just going to change around the operators when we paste it, and the name. So we have less than or equal to, less than, equal to, and this one should be equals equals. And then we have not equals. Not equals is going to be, yeah, so this should just be not equals. Paste this again. And then we have greater than or equals, and that is greater than or equal. And then we have just greater than. And that's that. Okay, now we're done with comparisons. So then after that, we're going to add the math ones. So we have add expressions. Oh wait, that's already down here. So a math add expression, if it's a plus, if it's an addition one, we're going to take x, blank, and y, and we're going to copy paste this value code. We'll just take all of this for now. So we'll do x plus y. That should work. And then we need to do subtraction. So for subtraction, we'll do, it's called minus, oops, plus, minus, minus. Okay, add expression is done. Next we need the multiply expressions. So this can be times or divide. Times divide. Okay, and then we need the exponent expressions. Oh, these should be called multiply. This should also be called math multiply. And then this should be called math exponent. Exponent power is just x to the power of b, or x to the power of y. Ah, what? Not a and b, x and y. And then prefix expressions. So we have grab this. Or no, we'll just write it. Prefixes take, well, the first one, which is negative numbers. We'll take the blank, and it'll take a literal expression, which we'll just call e. And to do that, we'll do value x and value y. Or no, it has to be value e because it's just one of them. Oh, these are all wrong. This needs to be value x. And this one, this one, this one. Change all these. Why? 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 value y, value x, y, value x, value y, x. Okay, and then for negative, we'll do -1 times the value e. Then we have prefix expression not. Sorry. Okay, there. So we have prefix expression not, which is going to be e equals, oh wait, or value e. Value e equals, oh wait. So we get the value of e. And then we do just return not e. And of course later on we're going to add the type checking to make sure it's a boolean. So now that we have that, we can do literal expressions. So we're almost there. This we're going to add in the future. Can I not? Well, we're not going to add this one yet. This one we're not adding yet. All these ones we can add. Functions is going to be its own part. So there's that. And then we'll change this one to an equal. So we have literal expression. Expression underscore parentheses equals. This one is mainly just passing on the values of other interprets. So parentheses is blank, some expression, and then blank, and for this we just return the value of what's inside the parentheses. If we're doing true and false constants, we'll just do true is function. This needs to be a function. Async function. No, this does not need to be async. Yeah, we'll just make it async. And then for this we just return true because this is just the true. Literal expression false. We just return false. Literal expression number. We have to do this one next. Make it async. We have that, and then we have getting a variable. So this is the last part of setting up assignments, which is the only actual function of our thing so far. This video is getting long, so I'll wrap this up soon. But for this, we will just return environment. e.interpret. So what this will do is from our environment, because in the assignment we set earlier, we set in assignment we set environment value left to value right. So now we can retrieve the value right using from environment like this. Now the last part is if we're processing an identifier, which is like a name of a variable. It's if we look back over here, the identifier has its letter and then one or more alphanumerics, but we actually don't need to do anything here. We can return this dot source string, which will just get us the original string that it came from. Now a number is a function of we'll also, for this, we just do parse number underscore. Number needs to be, wait, let's see. Numbers, weird, because we have to convert text numbers to actual numbers. But I guess we can just do parse int or parse float. Let me look this up, I'll be right back. Okay, and we're back. We want to use parse float on this, so we'll just parse float of the source string. So this will just get the source string, and then we'll parse it into a number, and we'll return that. And we need to make these async. They don't need to be, but it just helps with the uniformity. So now we are done setting up all the little bits and pieces of all our expressions. So that's all we have time for this episode. In the next episode, we're going to be finishing programming, running the program, and we're going to be programming in future episodes type checking and big integers and more features like control statements and all that other cool stuff. So I'll see you in the next part.